I'm talking about science set free, and what science is being set free from is the science delusion. The science delusion is the belief that science has already understood the nature of reality in principle, leaving only the details to be filled in. This is very widely believed in our society. It's one of the reasons for the dogmatism that all of us encounter, which is so annoying, but it's because people think they already know the truth. They sincerely believe that, and this is probably one of the most widespread delusions in our society, and we've now exported it to the rest of the world. There's a conflict in the heart of science between science as a method of inquiry about the testing of hypotheses, looking at the evidence, finding out what's really going on, open-minded, subject to correction, and so forth. The ideal of science, which many people think of as what science is. Now, it's what science ought to be, and I agree with that ideal. The reality, as many of us have encountered through bitter experience, is rather different. For many people, science has become a belief system, a worldview. This is sometimes called scientism, where people take the dogmas of science to be a kind of religious belief system or quasi-religious belief system. And it's this dogmatic belief system which I think is now constricting and holding science back in a very serious way. In almost every branch of science, we see the law of diminishing returns. More expensive research yields fewer and fewer really new results. And I think the reason for all that is this dogmatic belief system. If science can be set free from it, new experiments and new possibilities open up in every area. What I do in my book, Science Set Free, is take the 10 dogmas of institutional science, which are part of the scientific worldview, and turn these dogmas into questions, treat them not as beliefs or truths, but as hypotheses that can be tested against the evidence. I then look at them scientifically to see how well they stack up when you take into account the evidence. None of them do. And in every case, new possibilities open up. Science would become regenerated when we undergo this process. I don't have time to discuss all 10 dogmas today, but what I'll do first is just say what they are. And first and foremost, dogma 1 is the belief that nature is mechanical or machine-like. This has been the foundational principle of science since the beginning of modern science in the 17th century. Mechanistic science is based on the machine metaphor. Nature is a machine. Stars are machines. Animals and plants are machines. That's why you can have industrial agriculture, genetic engineering, factory farming, and so on. They're just machines. And we're machines too, lumbering robots, in Richard Dawkins' vivid phrase, with brains that are genetically programmed computers. The second dogma is the total amount of matter and energy is always the same, except at the moment of the Big Bang when it all appeared from nowhere. Then the third dogma is similar to that. The laws of nature are fixed. The laws and constants of the world are the same today as they were at the moment of the Big Bang, when they all suddenly appeared like a kind of cosmic Napoleonic code. As Terence McKenna used to say, modern science is based on the principle, give us one free miracle and we'll explain the rest. And the one free miracle is the appearance of all the matter and energy in the universe and all the laws that govern it from nothing in a single instant. The fourth dogma is that matter is unconscious. The universe is made up of totally unconscious matter. Fifth, nature is purposeless. There are no purposes in nature, and the evolutionary process has no purpose or direction. Sixth, biological inheritance is material. It's genetic in the genetic material DNA, or possibly in epigenetic modifications of the DNA, which are also chemical, or in cytoplasmic inheritance, but at any rate, it's all material. 7, memories are stored as material traces inside the brain. Everything you remember is somewhere inside your head as a stored memory, either in phosphorylated proteins, modified synapses, or some material form which has not yet been fully identified. So the details are very vague. Attempts to find these traces have failed over and over again, but nevertheless, it's universally believed within neuroscience that they're all inside the brain. Dogma 8, the mind is inside the head. Mental activity is brain activity. Your mind is nothing but what goes on in your brain. Dogma 9 follows from Dogma 8. Psychic phenomena are illusory. Things like telepathy can't really happen because they would imply the mind can work at a distance from the body, and it can't do that because it's all inside the head. And Dogma 10, mechanistic medicine is the only kind that really works. Alternative and complementary therapies may appear to work, but that's only because people would have got better anyway, or it's all the placebo effect. But the real kind, the only kind that really works is mechanistic medicine, which is why in most parts of the world it's the only kind taught in medical schools, it's the only kind funded by government funding agencies, and so on. Well, these are the 10 beliefs which are more or less the default belief system of most scientists and most educated people today. Wherever they are in the world, in India or China or wherever, this is the belief system which is predominant. Now, within science itself, of course, people at the leading edge of research in many ways have moved beyond this belief system. Research scientists are not necessarily committed to this in every detail, but they're usually only at the frontier of one region. A physicist might be at the frontiers of cosmology and have gone beyond some of these dogmas of physics, but they wouldn't question the dogmas of psychology or biology. Those would remain more or less intact. So there are various people who question bits of it, but there's very little that's been done to question the whole thing. This is essentially the materialist worldview, and it became the dominant view of science in the 19th century. Science was, as it were, hijacked by materialist philosophy, and since then has been a wholly owned subsidiary of materialism. There's no reason why science has to be materialist. It wasn't materialist before the 19th century. It was dualist, as I'll say soon. And I think we can go beyond that to a new, more inclusive, more organic, organismic paradigm for science. What I'm going to do first is look at the dogma that the total amount of matter and energy is always the same. This got built into the foundations of science in the 17th century. It was not brought about by incredibly detailed observations using nanogram balances and so forth. It came about for purely philosophical or rather theological reasons. The founding fathers of modern science were all Christians who believed that the world was a machine, that God was a machine maker, an engineering, mathematically minded God who'd created the world machine, and he'd started off the world machine in the first place by creating the matter that's in it, which he created in the form of atoms, taking the idea from Greek atomism. And these atoms, by definition, couldn't be destroyed, they couldn't be broken up. So once God had created them, the total amount of atoms, or matter, must automatically remain the same forever. And God also endowed the universe with a certain quantum of movement or force, which started it in motion, and thereafter, because this God-given force couldn't be changed by anything else, the amount remained the same. So the principles of conservation of matter and energy were built into science from the outset. Not on the basis of detailed measurements. They've served as useful accountancy principles ever since, but they were formulated more rigorously in the mid-19th century in the law of conservation of matter and energy and in the first law of thermodynamics. So it was assumed that that was the end of the matter and that they were fixed forever. And most people take that for granted today. They've learned it in high school and they never see any reason to question it. This was the dogma of science which I myself didn't question until quite recently. I'd questioned all the others, but it was only when I was writing this book that I thought I should look at this one. And I actually rather wanted it to turn out to be true, because I thought if I said that all 10 dogmas of science were false, it might sound a bit biased. So I thought it'd be quite nice if one of them held up, and I thought this was the best candidate. But when I thought about it, it turned out to be a shambles. First of all, physicists are above the law, and they've found themselves quite free to invent or hypothesize forms of matter and energy that which no one had ever thought of before. One of them is, of course, dark matter. Observations of galaxies and the way that stars moved within them, and also the ways that galaxies interact with each other, suggested that the galaxies, if they were to be explained in terms of gravitation, simply wouldn't work. The whole thing simply didn't work. So in order to make it work, they hypothesized there was extra matter, which you can't see, hence the name dark matter, that accounted for all the phenomena of galaxies and their interactions. Well, how much dark matter was there? Well, simple. Just invent the exact amount you need to explain the observed phenomena. You can titrate the amount of dark matter at will to explain the phenomena you're trying to explain. If you find new phenomena, peculiar bulges in galaxies or something that one-size-fits-all dark matter won't explain, then you add a bit more where it's needed. The system works perfectly, and you can explain everything with complete accuracy because you can change the amount at will. The only trouble is no one knows what it is, and there's no independent evidence for it. People have been speculating about its nature ever since it was first postulated. Having created all this extra matter in the universe, then this meant there should be more gravitation, and physicists expected in the 1990s that the universal expansion from the Big Bang would slow down, the universe would stop expanding, then begin to contract under the influence of all this gravitational matter, until it ended in tears, in the reverse of the Big Bang, known in the trade as the Big Crunch. So when in the late 1990s people observed that the universe appeared to be accelerating because of red shifts in distant quasars and so on, in galaxies, then there was the problem, how do you explain this acceleration? Well, the answer was ready to hand, a new form of energy no one had known about before, which caused the universe to expand. How much is there? Well, just the right amount to explain the facts. So we now have dark matter and dark energy as huge amount of the universe. They currently make up about 96% of reality. Now, physicists have invented something like 20 times more energy and matter than anyone had ever heard of till the 1980s. And no one's said, oh, you can't do that. It's defying the law of conservation of matter and energy. And if you ask, is all this matter and energy conserved? Is the total amount always the same? Well, for dark matter, nobody knows. For dark energy, the most usual theory is that actually the amount's increasing. As the universe expands, there's more dark energy. The universe is now a perpetual motion machine. So the idea it's all rigorously conserved doesn't really make much sense in those terms. There's also, within quantum physics, zero-point energy, a form of energy which is supposed to be there underlying the world we live in, which is like waves on an ocean of energy. And there's huge amounts of it. The amount in a teaspoon would be enough to power the United States for years. Not surprisingly, some people claim that they can tap this energy and have devices which tap unconventional or unknown forms of energy, including zero-point energy. If you go online, you'll find there are many people who claim to have above-unity devices, machines that produce more energy than you put into them. Well, these are immediately banned from regular science because they violate the first of science's taboos established by Galileo in the early 17th century, the taboo against perpetual motion machines. This taboo long predated the laws of thermodynamics, and it's one of the most deep-seated taboos in science. So things like cold fusion or above-unity devices or free energy devices, whether they're based on zero-point energy or peculiar electromagnetic effects or parametric resonance or the various other theories that are used to explain them, are totally beyond the pale. Nevertheless, people claim they've got them and they exist. If they do exist, of course, it would totally transform the world economy and the world energy situation. So do they really work? Well, right now it's very, very hard to find out because there's claims that may or may not be substantiated. There's a universal rejection within orthodox science of this. A few people within the Department of Defense, a few people who, as a kind of maverick investors, are interested in this. The Japanese government's interested, but basically they're not part of the normal discourse of science. I myself think the best way forward here would be to have a prize, say $1 million prize for the best above unity device. And those who claim to have them could then have them tested. This is not an attempt to debunk them. It's an attempt to see what really works. They'd be tested under fair, agreed conditions. And if any of them do indeed produce more energy than is put into them, and that, which can't be explained in terms of any known energy source, they'd win the prize. If the several do, then the best one would win the prize. I think this would be the best way of bringing this whole thing out into the open and finding out what's really going on. And I think that, commercial betting companies could open a book on this as well, and people could bet on whether the prize will be awarded. Then all those skeptics who say it's impossible could put their money where their mouth is and bet $1 million that no one would win the prize. How much would they actually be prepared to bet? That would be a very interesting question. I'd be prepared to bet at least $1,000 that someone would win it. So I think this would put the thing totally into the public domain. The media would love it, everyone would be discussing it, and if someone won it, I think it would completely change the climate. I think investors would get interested, governments, how it works, and the situation could move on. Right now we've been at a stalemate for years with these things. It turns out that in biology, the whole question of energy conservation is much, much more questionable than most people assume. We all assume that the total amount of energy that we produce can be explained by the food we take in. And this was assumed in the 1850s by Hermann von Helmholtz, who was eager to prove that living organisms were nothing but machines. He didn't prove it, he assumed it, and since then it's been a basic dogma of biology. It wasn't tested in humans until 1899 by two American researchers called Atwater and Benedict, and they were determined to prove that we're nothing but machines. They were mechanists, and they started from the assumption this was true, and they did the experiments not to find out if it was true or not, but as they put it, to demonstrate it in order to further the cause of science. They had people in calorimeters and measured all the heat produced, the carbon dioxide, the oxygen taken in, feces, urine, food consumed, and so on, did a complete energy balance sheet. When they did it, the results came out wrong. So they changed the correction factors for the value of food until they got the expected result. And this then became built into the foundations of biology as a certain fact. It wasn't re-examined till independent-minded American nutritionist Paul Webb redid their experiments in the 1970s. He found huge discrepancies. People who were overweight, overeating, and doing very little exercise seemed to have 25% or so of the energy just vanish. People who were not eating and doing exercise gained about 25% too much energy. Where was it coming from? Nobody knows. He called it X, the unexplained amount of energy that could either disappear or appear. He then re-examined Atwater and Benedict's results and found that they'd got similar discrepancies, but they'd made sure there were just as many people who had too much and too little, so that when they averaged them, it cancelled out to give the expected result. There are people who claim there are other forms of energy, chi, prana, vital energies, and so on. And these are usually treated as metaphoric, but they may be much more literal than we usually think. And this is a huge unexplored area. It's not as if nutrition science is the most successful branch of modern biology. I think that this is something which bears re-examination. In my book, I suggest several quite radical experiments that could be done quite simply and cheaply to look at this. Well, now let me turn briefly to the idea the laws and constants of nature are fixed. The idea the laws are fixed is a hangover from Greek philosophy. Plato and Pythagoras thought that the world was governed by mathematical principles beyond space and time, eternal ideas. In the 17th century, people thought these were ideas in the mind of a mathematical God, and that God had these mathematical ideas, and that scientists were actually finding out about the mind of God by finding out the maths of nature. People thought Newton's laws of gravitation were not just human hypotheses. mere guesses or mere working principles. They thought this was a direct insight into the divine mind superior to that of religion, much more precise, much less disputable. And this was really the basis for Enlightenment ideology of science and reason. They thought science and reason transcended religion in giving a direct insight into the divine nature. Now, you don't hear much about that today, but there's still this strong Enlightenment tradition, and the idea of the laws of nature are fixed is a hangover from that point of view. But in a radically evolutionary universe, which the Big Bang postulates, why shouldn't the laws of nature themselves evolve? In fact, why should there be laws at all? Law is a very human metaphor. Only humans have laws and only civilized societies. Why should we project this anthropocentric metaphor onto the whole of nature? I myself think that the idea of habits of nature makes much better sense. This is the basis of my own idea of morphic resonance, which is a memory principle in nature. But I'm not the first to propose habits. The American philosopher C.S. Peirce, at the beginning of the 20th century, suggested that in an evolutionary universe, the regularities could be thought of as evolving habits. I think it's a much better way to think of it. And it's a testable hypothesis. The theory of morphic resonance predicts, for example, that if you crystallize a new chemical compound for the first time, it may be very difficult to crystallize because it hasn't yet got a habit to crystallize with a particular lattice structure. But if you crystallize it again somewhere else, there'll be a resonance from the first crystals across space and time, morphic resonance, that will make it easier to crystallize, and the third time it'll be easier still because of resonance from the first and the second crystals. It'll get easier and easier to crystallize all around the world. There's a lot of evidence that that really happens. Chemists explain it by saying there must have been fragments of previous crystals must have been wafted around the world as dust particles, but I'm predicting the same will happen even if you filter dust particles out of the air. The theory also predicts that if you train an animal, say rats, to learn a new trick, if you train rats in Albuquerque to learn a new trick, then all over the world, rats in New York and London and Tokyo should learn the same trick quicker just because the rats have learned it here. Surprisingly, there's already evidence from experiments with a long series of experiments with rats done at Harvard, the University of Edinburgh and the University of Melbourne, Australia, that this actually happens. The same applies to people. It should be getting easier to learn things that others have already learned. Well, I'm not going to go into detail on this because this is the theme of my own theory of morphic resonance, and my purpose in this lecture and in my book is not really so much to push my own ideas as to show how questionable the standard ones are and how much we can, the field is open for different answers. But I'll turn just briefly to the constants of nature because this affects the electric universe, or indeed any model of the universe. It's assumed that the constants of nature are constant, the fundamental constants, like Newton's gravitational constant, big G, or the speed of light, c. Well, I began to wonder whether they really were constant when I got into the habit view of nature. And so I tried to find out what the actual values were. I started off by getting handbooks of physical constants and looking at old editions. Most people only look at the latest edition, and they usually throw the old ones away. But in the Patent Office Library in London, I found they kept them all. And so I got them all out of the reserve stock at 10-year intervals. They wheeled in a trolley of handbooks of physical constant, dusting them off. And I looked through these things to see how they'd changed. To my amazement, I found that the speed of light dropped by 20 kilometers per second between 1928 and 1945. I then looked up the data in more detail and found that all over the world people have been getting this much lower figure with very small error bars. The original figure is up there with little error bars, and it goes down much lower with little error bars. It wasn't as if the error bars were 20 kilometers per second. No, they were decimal places of kilometers per second. I checked in the primary literature and found this indeed seemed to be the case, and then they went up again after 1945. I couldn't understand what was going on, so I asked the head of the metrology department, metrologists are the people who measure constants, at the British National Physical Laboratory if I could go and see him, and I went to visit him. He was very friendly. And I said to him, Dr. Petley, I'd like to know how you explain this drop in the speed of light between 1928 and 1945. And he said, oh dear. I said, what? And he said, you've uncovered one of the most embarrassing incidents in the history of our subject. So I said, well, could it mean that the speed of light really did drop, at least as measured on Earth during that period? He said, oh, of course not. And I said, why not? He said, because it's a constant. So I said, well then, I can't see any other explanation than that people all around the world were sort of fudging their results to get what they thought everyone else would expect them to get, and then discarding outliers and stuff, and coming up with these very narrow error bars that agreed with everyone else. And so then it must have been produced by some kind of fudging process. He said, we don't like to use the word fudge. And so I said, what do you prefer? And he said, we prefer to call it intellectual phase locking. So I said to him, well, if it was happening then, how do we know it's not happening now? And he said, oh, we know it's not happening now. And I said, why? He said, because we fixed the speed of light by definition in 1972. So I said, well, it might still vary. And he leaned back, looking very smug, and said, well, if it did, no one would ever find out, because we've defined the meter in terms of the speed of light. So the units would vary with it. So I said, well, okay, you fixed that one, but what about the gravitational constant? I said, that's been varying wildly, and even actually in the last 3 or 4 years, it's varied by more than 1.3% as measured in different laboratories. The usual assumption is this is just error, and it's experimental error, it's hard to measure, it's error. So labs all over the world get quite different results, and the International Committee on Metrology fixes the results every few years by averaging ones from different labs, weighting ones they think are more reliable, discarding ones they think are not. And indeed, when I left Dr. Petley, thanking him for his time, he reached down to a cardboard box beside his desk full of pamphlets. He said, by the way, these have just come from the printers, you might like one. He handed me this pamphlet, The Latest Values of the Physical Constants. I looked at these data from different labs on G, big G, and in one or two, the question that I was wondering is, there's all these big errors. Could it be that they're actually changing together in different labs as the Earth rotates around the Sun, as it rotates during the day, and as the whole solar system moves through different astronomical environments? To find that out, one would look at the day-by-day measurements from different labs and see if the errors, or so-called errors, are correlated. I've spent more than 10 years trying to persuade metrologists to do this, and they simply will not, because they say it's a constant, so there's no point looking for variations. But I say you've got these huge differences, and they say, oh, they're just errors, it's hard to measure. But they simply won't do it. An exercise in open science would be if they put their raw data with the dates online, and then there could be anyone could try and look for patterns, and there could be a website where they're discussed. I think it would cost nothing, and we might find something out. We'll find out nothing by pretending it's fixed. There are, in fact, already papers that suggest diurnal variations in accordance with the sidereal day. A group at MIT recently found a daily variation, and there's some evidence of annual variations. But there may be other wilder fluctuations that happen in concert. I myself think the so-called physical constants may vary from time to time, possibly even chaotically, within certain limits. But I think the day may come when, in scientific periodicals like Nature, there'd be a page a bit like the stock market reports, you know, this week's value of the constants, you know. This week the G was slightly up, the charge on the electron held steady, there was a drop in the fine structure constant, you know. And if that were the case, then it would give varying qualities of time when different things could happen. The idea they're all rigidly fixed is a hangover from an old Platonic point of view, way of thinking. So there, right in the heart of physics, is, I think, a really open and interesting question. The key revolution in the scientific revolution of the 17th century was the shift from an organic view of nature to a machine view of nature. It was a revolution because it rejected what people thought before. And what people thought before was a philosophy of nature taught in the medieval universities of Europe based on Aristotle as refined by St. Thomas Aquinas in the 12th century. And it was a very sophisticated philosophy of nature. According to Aristotle and St. Thomas, all living beings had souls. And the soul of a living being was not some metaphysical thing to do with life after death. It was what gave it its form, its structure. The body was in the soul was not in the body. And the soul gave each kind of plant its form, its leaves, its flowers, its roots, its shape. And the soul worked by attraction. As the tree grew, it was attracted towards the mature form by the soul of the plant. It was like the form. In addition, animals had, as well as the vegetative soul that shaped their embryos and growth of the body and maintained its health, there was the animal soul, which was concerned with instincts, sensations, and movements. And of course, the word animal comes from the Latin word for soul, anima. Human beings had a vegetative soul that shaped the body, an animal soul that gave us our animal nature, our senses and instincts, and so on, are very similar to those of animals. But in addition, the rational or intellectual soul to do with reason, language, the mind, consciousness. But nobody thought that the human mind was totally separate from the rest of nature. It was embedded in a psychic system which connected us to animals and plants. And the whole world was alive. The earth was alive. The planets were alive. We still call them by the names of the Roman gods and goddesses. And the stars were alive. They were intelligent beings. Each star in the sky, as people looked up, was filled with an intelligence. One of the levels of angels, the dominations, virtues, and powers, the three levels of angels in the hierarchy, the ninefold hierarchy of angels, were the spirits or intelligences of the stars. So when a medieval person looked at the sky, they looked at a living universe filled with the presence of God. Every star was a living, intelligent being. Now, the mechanistic revolution replaced that with the idea that everything's a machine. A machine is a bit like an organism, except it no longer has its own design or purpose. Those are put into the machine from the human designer or maker. And this metaphor meant God was the intelligent designer of the machinery, and it's through divine intervention that the whole world had been made in the first place. The organic view of the Middle Ages was really a form of Christian animism. Plants and animals had their own purposes, their own desires. The soul gave them their motivation, their goal. The whole of nature had a purpose. It was striving towards the being of God, striving towards perfection. God was the prime mover of the universe, not by pushing it from behind, but by attracting it from the future. That view was destroyed and replaced by a machine view. The heavens became dead matter. The solar system became a mechanical clockwork-like system. Animals and plants became mere machines with no feelings, so it was all right to vivisect them or treat them appallingly in factory farms. The only thing that was left that wasn't mechanical in the world was the human rational mind. And that was the only thing left, except for angels and God, which were immaterial spirits like the human mind. This was Descartes' view, and it created an extreme dualism of body and soul, matter and spirit. So for Descartes, the whole world was mechanical, made of unconscious matter. Consciousness existed only in humans, angels, and God, and was separate from the rest of nature by being immaterial, not in space and time. This created a radical dualism between people and animals, mind and body, and between religion and science, because science got the realm of spirit, human minds, angels, and God, and religion got that, and science got the whole of the physical universe, including the stars and the heavens, which now became dead, unconscious, and inanimate. Well, that was the revolution, and matter in this view was defined as unconscious. No one did experiments to accurate to many places of decimals. It was simply defined as unconscious by Descartes, and it's remained so ever since in the view of scientists, without further discussion. Now, Cartesian dualism, could I have a glass of water, please? Cartesian dualism was unsatisfactory for many people. By the 19th century, a lot of people didn't want to have two fundamental principles. They thought two was too many. They wanted to have just one. And thank you. And dualism, this view that it's too many, meant that they tried to collapse it into one of these two principles. The idealists said everything is consciousness. Matter's just a kind of dulled down spirit or consciousness or mind. But the more popular view was the materialist view. Everything's matter. There's no such thing as this mysterious non-material spirit of the human mind, and certainly not angels and God. So at one stroke, the materialists wiped out angels and God and said the human mind is nothing but the activity of the brain. They collapsed it down into the brain. And that is the view that took over science by the late 19th century and has been the standard paradigm ever since. Of course, it creates appalling problems, and one of them is that it makes human consciousness inexplicable. If matter's unconscious, how come we're conscious? Well, some philosophers of mind, materialist philosophers, say, well, there's a simple solution to that. We're not conscious. The mind is just an illusion. We're just machines. That's called eliminative materialism. And in the United States, throughout much of the 20th century, the official doctrine of academic psychology was behaviorism, which denied the existence of consciousness. It said the only thing you can measure objectively and scientifically are muscular movements and glandular secretions, and that's what scientific psychology should study, ignoring the folk belief in consciousness. Others take the view that consciousness is nothing but an epiphenomenon, a bit like a shadow of the activity of the brain that does nothing. And others take the view that consciousness is an illusion produced by the brain to make us feel good and get out of bed in the morning because it makes us feel good but doesn't actually do anything. None of these views say that consciousness does anything. We don't have free will. It doesn't actually do anything useful. It might just as well not be there. We might just as well be zombies or robots. And it's irrelevant to science because it doesn't really exist. The trouble is that this isn't a very convincing view even for materialists. I mean, they'll argue it at work, but as soon as they get home in the evening, they don't treat their spouses, their children, and their dogs as if they're inanimate machines. And they themselves don't believe that they're materialists because their brain makes them believe it. They like to think they're materialists because they believe in science, reason, and evidence. Yet their entire philosophical position undermines their belief, their belief in materialism. It's incoherent. That doesn't stop it being the dominant philosophy in all our universities and in almost all philosophy departments. It's the dominant view. But it's so incoherent and so difficult to square with observable facts that within consciousness studies, this is now very, very much disputed. There's been a breaking away from materialism by leading philosophers. One of the first to break away was Galen Strawson, a British philosopher who lives in America, who wrote a key paper a few years ago called "Does Materialism Imply Panpsychism?" to which he answered yes. Panpsychism is the idea that there's a kind of mental aspect to all kinds of nature, even electrons. And although he didn't give any details, he said this was the only coherent way we could explain the emergence of consciousness in humans. Because if you try and conjure it out of totally unconscious matter, it's really just reinventing dualism on a kind of evolutionary basis. More interestingly, and I think more coherently, the American philosopher Thomas Nagel wrote a book a few months ago, which I think is a breakthrough in modern philosophy. Nagel is a leading philosopher of mind in New York, and his book is called Mind and Cosmos: Why the Materialist Neo-Darwinian Conception of Nature is Almost Certainly False. His book was hated by the materialist militant atheist crowd. He was denounced as going off the rails and that kind of thing, but it's a deeply thoughtful and fascinating book. But of course, panpsychism is not new as a philosophy. It's what people thought in the Middle Ages, basically. And in the 17th century, soon after Descartes, in the next generation of philosophers, people were already exploring this possibility. One of them was Leibniz. And Leibniz argued that the universe is made up of monads, units of organization, including us, but also including atoms, and that every monad, as well as having a body, has a mind, and each monad reflects the universe from its own point of view. So every monad has a completely different point of view because it's in a different place. Like everyone in this room has a different point of view because we're all in different places. We can't all be in the same place at the same time because bodies are impenetrable. And so that was one panpsychist view. Another was Spinoza, who said that the whole of nature is the body of God, and it has a consciousness or mind, the whole of nature. It's God or nature. It was a kind of pantheistic view. The most important philosopher in this tradition in the 20th century was Alfred North Whitehead. And Whitehead argued that all physical systems that are self-organizing have a mental aspect. Self-organizing is a key here. This doesn't apply to chairs, tables, motor cars, and so on. They're not organized, they're put together by an external force, humans. But things that organize themselves include atoms, molecules, crystals, cells, animals, plants, ecosystems, planets, solar systems, and galaxies. Those are self-organizing systems. And Whitehead argued that all self-organizing systems are processes in time. There's no such thing as enduring matter like little billiard balls. He was the first philosopher to appreciate the importance of quantum theory. And what quantum theory shows is that even electrons are waves. They're waves, wave-like patterns of activity. They're processes, not things. And if they're processes, they take time. You can't have a wave at an instant. That's the fundamental reason for quantum uncertainty. You can't have an instantaneous wave at an exact moment of time because a wave takes time. That means a wave has a future pole and a past pole. It's a process. And his philosophy is called process philosophy. And so even an electron has a future and a past pole. And Whitehead's most original contribution, in my view, was the way he understood the relation of mind and body. Usually people think of it in terms of spatial metaphors. The mind is the inner life, the body is the outer world, or the outer part. It's the inner and outer. He thought the relationship was a temporal relationship. The mind is the future pole, the body is the past pole. In an electron, the Schrödinger wave equation describes all the possible things that electron could do. Those possibilities coexist. They're not physical, material, measurable realities because they're possibilities. It's a different kind of thing. But as soon as the electron interacts with something or is measured, then these possibilities collapse down to one physical, observable fact. That's now in the past. The physical pole is in the past. And now a whole new realm of possibilities develop. The same with our conscious minds. They're filled with coexisting possibilities. Our minds are realms of possibility. Mental reality is a realm of possibility about potential futures, virtual futures, things we could do. And our minds are involved in choosing among these possibilities. As soon as we choose to do something and do it, it becomes an observable physical fact, objectively measurable. But before that, it's a possibility. And this gives a view of causation, a twofold form of causation. Possibility, mental causation, working from virtual futures towards the past, and regular physical causation working from the past towards the future, and they overlap in the present. I think this is the best way of thinking of the relation of mind and body, the most fruitful. It has many implications, and I don't have time to go into them all now at this moment. What I do want to do is just explore what this panpsychist view might mean when we look at big things. Most discussions of it are about atoms and electrons. But since we're here at the Electric Universe Conference, what about thinking about the sun and the galaxy? The sun is a self-organizing system. Indeed, the whole solar system is a self-organizing system. It's not put together in a factory. It organizes itself. And the entire galaxy is a self-organizing system. From that point of view, they're organisms. And from Whitehead's point of view, that would mean they would have a mental pole, which would be to do with potential futures, and a physical pole, depending on the decisions or choices made among those possible futures. What we observe is the physical pole. But they have a great deal of indeterminate activity going on in them, particularly electrical activity, electromagnetic activity. We know there's no dispute that the sun is highly active electromagnetically. However one interprets the source of its energy, everybody agrees that there's highly complex electromagnetic patterns are going on there. People also think that the interface between our brains and our minds are the complex electromagnetic patterns going on inside our brains. So what if these electrical patterns in the sun are an interface with the sun's mind? What if the sun thinks? Now, as soon as you raise that question, you realize this is an utterly taboo subject. You're not allowed to ask that question. It's matters unconscious. Since the 17th century, materialists have assumed, and dualists, had assumed that matter's unconscious. It's simply off limits. However, all traditional cultures have treated the sun as alive, and indeed the planets and the stars. Children, when they draw the sun, draw it with a smiley face. And so this in itself is taken as evidence against the fact that the sun can be alive or conscious, because if children see it that way, it shows it's a primitive, childish way of looking at things. And the fact that people all over the world show it that way until science comes along, again, proves it's primitive and superstitious. We've risen above it. I don't think we've risen above it at all. I think we've sunk below it to a level of dogmatism which simply closes off a whole area of questions for no reason other than the fact that a French philosopher in the 17th century chose to divide up the world in such a way that he defined matter as unconscious. It's become a habit of thought with us. About 10 years ago, with a few other people, I organized a small invitational conference in England. We held it over the the summer solstice in the countryside, called Is the Sun Conscious? We spent several days discussing the consciousness of the sun. Well, of course, none of us could really prove the sun was conscious, and you might say to me, well, if it's conscious, prove it. Well, my answer to that is, well, you can't prove it's unconscious. It's actually an open question. But once we got beyond discussing what it might mean, we then got on to the question of, if the sun does think, what does it think about? Well, one obvious thing would be its body, which is the solar system, right out to the heliopause. And it knows what's going on in the solar system. It's pervaded by the sun's electromagnetic field. Everything in this room is within the sun's electromagnetic field. The electromagnetic activity in your brain is within the sun's electromagnetic field. So the sun, in a sense, just through the electromagnetic field alone, would be able to sense what's going on in the entire solar system and beyond. And its decisions might involve, when to send out coronal mass ejections, whether timing of solar flares, whether to point them towards the Earth or not. There's all sorts of things, and also the variable cycles of the sun may be reflections of its psychic activity. So part of its concern may be with its body. Part of it may also be with its peer group, the other stars. And the galaxy as a whole, you see, may have a mind. I loved that talk yesterday by Michael Claridge, where he conjured up this wonderful image of variable currents moving through the arms of the galaxy with more activity in some places than others, changing from time to time, like fMRI scans of the brain change when you're thinking about one thing or about another thing. The entire galaxy is a living organism. With a mind as well as a body. The electric universe aspect of this is the perfect interface between the physical activity of the galaxy and its possible mental life. Of course, if we start thinking and say, why stop at galaxies? You've got galactic clusters and then you've got the entire universe. What if there's a cosmic mind? Well, this is by no means a new idea. But I think that science itself can open up something. We're not talking now about supernaturalism or blind faith. We're talking about a way of thinking about nature which gives us an organic, coherent view of nature and opens up completely new ways of forms of dialogue with spiritual and religious traditions. I want to end by just reflecting for a few moments on the location of our own minds. The normal view is there the activity of the brain, it's inside the head. But this leaves a great many things unexplained, including vision. What's going on when you see something? What's going on when you see me now? Well, light moves from me through the electromagnetic field, enters the eyes, inverted images on the retinas, changes in the cone cells, impulses up the optic nerves, and changes in various regions of the brain, which can be illuminated through brain scanning. We know more about them than ever before. Does this explain vision? Well, no, it just describes changes in the brain. The first thing about vision that isn't explained is the fact you're conscious of what you see. That's an example of the hard problem in consciousness studies or philosophy of mind. The very existence of consciousness is unexplained. But then there's the question of where are the images you're seeing? You're seeing a three-dimensional colored world. The conventional view is that all that's inside your brain. You've got a virtual reality display somewhere inside your head, which includes me and the rest of this room and everybody else here. It's all in your head. If you look at the sky at night or in the day, the sky you're seeing is inside your head. A key paper recently in one of the consciousness journals by a philosopher of mind was called, "Is Your Skull Beyond the Sky?" And the author of the article answered yes. He's a materialist, so he said the mind's in the brain, everything you experience is inside your head, your skull's beyond the sky. This is only a virtual skull, but your real skull is beyond the sky. Everything you're experiencing is inside your head. Your whole conscious, subjective life is inside your head. I propose a much simpler view which takes into account our own direct experience. It's so simple it's hard to grasp. And that's that your image of things is in your mind but not inside your head. Your image of me is exactly where it seems to me be, outside your head, where I'm standing. Vision's a two-way process. You project out images which coincide normally with what you're looking at. This means that there's a kind of outward movement of the mind. The mind's not confined to the inside of the head. It's extended out through attention and intention. And that means we should be able to affect things just by looking at them. And that means, for example, that if I look at you from behind and you don't know I'm there, you might be able to feel my gaze. Now, could that possibly be true? Well, as soon as you ask that question, you realize it's a common experience. More than 90% of people have experienced being stared at from behind. You turn around, there's someone looking at you, or staring at someone and making them turn around. There was an almost complete taboo on this in science until the 1980s. Because it simply doesn't, it ought not to happen, so skeptics dismissed it. It doesn't happen, it's an illusion, it's just folk belief, superstition, it's coincidence, selective memory. Experiments, however, show that it does seem to happen. There's now a lot of experimental evidence. People can really tell when they're being looked at from behind. That can't be explained just in terms of sounds or smells. It works through glass, works through one-way mirrors, even works through CCTV. Now, this means that our minds reach out to touch what we're looking at. And I just want to leave you with this thought as when we're talking about the extended mind. When we look at the stars, it means that our minds, from this point of view, are reaching out over literally astronomical distances, contacting those stars. Now, the question then arises, if the light takes, say, 10 light years to get from a star to our mind, when we project out our image of the star, is it just stretching out in time and reaching the star 10 light years after it was emitted? Or is our conscious mind working backwards in time and contacting it 10 light years in the past? I think it's contacting it when the light was emitted, 10 light years in the past. I think our minds are stretching out in time as well as space. And I think our conscious minds work backwards in time, as it were. This means that when we look at the universe, the electric universe, the stars, the planets, not only may we be looking at a living organism, the whole universe is a living organism with the galaxies and the solar systems within it as living organisms, but our minds are stretching out to contact it. It's not just something inside our heads, these ideas. When we look at the stars, directly or indirectly through telescopes, our minds are reaching out into the cosmos and maybe interacting with it in ways we can barely begin to imagine. Not just with potential little green men on other planets, but with the stars themselves, with the galaxy itself. So I think that the electric universe, which gives us an organic view of galaxies and solar systems as organisms held together by electric activities and plasma, is completely consistent with the emerging view of nature, the post-mechanistic view of nature, as the universe as a living organism, made up of many levels of organism within it, each organism containing smaller ones. The galaxies contain solar systems, they contain planets, ecosystems, species, social groups. Organisms contain organs, cells, molecules, crystals. A living universe with habits evolving in time, and one of which we're living parts. I think this is a view much more consistent with our experience of nature, a much healthier view of nature, one that breaks down that artificial division between mind and body, humans and nature, which the mechanistic theory gives us, and contacts us with the traditional wisdom of all traditional societies, which have all seen the universe as alive and organic. And I think we're rediscovering that at a higher turn of the spiral. I think as we move beyond the dogmas of materialism, science can be set free in almost every area. In medicine, in astronomy, in cosmology, in biology, in psychology, in chemistry, in our understanding of evolution. So I think instead of knowing almost everything, which is the common assumption, we know very little indeed. And the dogmatism we all encounter comes from a belief system, a worldview, which has long outlived its usefulness. It's long past its sell-by date. And as we move on from it, science will be set free in all sorts of ways, and I think we'll see a scientific renaissance. And I think this gathering is part of it. Thank you.